Welcome back. Welcome back, everybody. I was able to adjust my sleep schedule again. As you can tell, it's a normal time for me again. However, that also means it's now later in the day for me. I got up at like 6 a.m., starting to feel tired. So let's see how it goes. Nothing special for today. Yeah. Cool. There's one thing that happened since last stream, and that is we have a new emote. It's the green bunny from the older Live Overflow videos. So that's cool. And thanks to Enigma, who has subscribed while I was offline. Anyway, one other thing arrived. I got 2 more sorting boxes for all the electronics that I had, like in that pile. So now it's pretty cool. Let me show you, because I have, so these new boxes are like 2-layered. Okay, that's a bit annoying to handle. Oh god damn it. Okay, got it. Because now I have all these ICs here, and I've labeled them all. Cool, right? So, yeah, that's the only thing kind of that happened. The doggy is also with me. He is right now down there. Come here. You want to say hi to stream? You want to say hi to stream? I have even a bit of food for you. There we go. Come on. Come here. He doesn't want to. Come here. Say hi to stream. Come here. Okay, he's so not motivated right now. Come here. Say hello to stream. There. Say hello. He really hates us. Yeah. Because usually he has to hang out with me in here. When his most favorite human in the world is not home, so he has to be with his second favorite human, and yeah, he doesn't like it. Yeah. Then one other thing, maybe I could mention it again. TyphoonCon, which is basically SSD that have been sponsoring the browser exploitation series, they still have a challenge available, and that challenge, there are prizes for first, second, third prize, which is $1,000, $800, and also free tickets to TyphoonCon 2020. So this has been unclaimed for quite a while. So there's another chance for you to give it a try. I will also announce this on Sunday with the new release of the next browser exploitation video, so then more people will see it, so you still have kind of a head start of hopefully more people attempting it. Did you finish the Google CTF? What do you mean with finish the Google CTF? This is like impossible as a single person? There's a massive gap between his first and favorite human, absolutely. I know what you mean with solving it. I say it's impossible as a single person to solve all these challenges. And I'm like, that's insane. Don't think that you need to solve all the challenges at the CTF. Like, that's not the goal at all. Be happy when you solve one, maybe 2 challenges if you feel brave. You don't have to deal with more. They are hard enough. Yeah, especially Google CTF, correct. Yeah, that's pretty hardcore. Yeah. Okay, yeah, nothing else to tell you. Let's just head. Oh my gosh, I realize I'm a lot more tired than usually. Thanks for the support, just support. Please have a look at remote control. Has there been a write-up out? Because I didn't really look at it, but my teammates looked at it and spent quite some time on it, and they couldn't solve it, couldn't make it work. I mean, the attack idea is kind of clear, but they couldn't pull it off. But yeah. All right. Okay. So let's see. Where were we? Last stream was pretty in a middle in the middle of the night kind of stream, at least for the EU people, so not many people were here, but we made quite some good progress. Basically, we have finished the RAM module, and so now you can, so we have these dip switches here now. There we go. These dip switches here to select the address. For example, we can select, so right now it's address 0, now it's address 1, also indicated by these LEDs here, address 2, and so forth. So we can select addresses, and we can also see its value that is stored in there. And with this dip switch, we can also set the value that we want to store. So for example, if we want to now store, so we have address 0 right now here, you can see all are off, and we want to store this value here now in that memory segment. We can now use that button here to do that. I guess this is kind of how I can get it onto the screen. I guess if I remove that for a moment. So let's write this value into that address. Boom. And now these two turned on. So this is written there. Now we can go to the next address, and we can store there another value like that, and let's store that. So now that is stored, and now we can switch back to the first address. Here we have the original value again, and here's the second address. So yeah, that's what we finished last time. Right, we should also reset wires. And then I guess we can kind of immediately head in, because I think the next video is troubleshooting the RAM, and it's pretty long, so I wonder if still something is kind of wrong with it, or what the deal with it is. So yeah, switch to laptop. There we go. All right.
And in this video, I want to power it up, test it out, and basically convince ourselves that it's working right. So we'll power it up, and it's on. You can see the clock is running, and we're going to switch to program mode. And so we have all zeros here. We have all zeros here, so if we push the button in program mode, it should write all zeros to memory. And okay, we're making progress. All right, so it looks like we wrote, oh, I think I see what's going on. Oh.
Okay, looks like we don't have these issues. Ours seems to work fine, so that's kind of cool.
Boy.
You program it exactly like what I showed you right now. You write the values, your program into RAM with exactly what what I just shown you. You select the address and the value you want to write into RAM, and that's how you write your program into RAM.
So I'm just looking very closely here, and what I see. So first off, I guess kind of explain what's going through my mind here. So we wrote zeros here. We wrote ones here, and whenever you see ones, one thing to kind of think, or maybe a possibility, is that one is sort of the default input. So if something's not connected, you get a 1 because all the inputs on all these 7400 series, 74LS series chips are pulled up to, they have like pull-up resistors on the inputs. So that makes me think that maybe this is hooked up sort of correctly. I guess we could test that actually if we maybe set that. Yeah, so if we set that bit, it's writing that.
No, this is not the guy from Computer File. Or maybe he was on there on an episode. I'm not so sure, but his name is Ben Eater. There you go, Ben Eater.
That there. If we turn that off, it's not writing it. But no matter what we set these to, I'm guessing it won't change. Yeah, so nothing happens there. So that makes me think that we got this hooked up right, we don't have this hooked up right. And the first thing that I notice, just inspecting it, I see that I might be off by a couple, or off by 1 here. So the power should be going to pin 16 here, and I see it's going to pin 15. And then also this ground should be going to pin 15. It looks like it's going to pin 14. But then I would expect, oh yeah, okay. So I do have this input from the dip switch. Bit 2 comes across, and that goes to pin 15. Of course, you can see that's correct, but it's just these 2 wires are just off by 1. So I just need to shift these over to the left. So let me pull the power off and do that. So this.
Now I'm kind of curious too. Ben Eater, Computer File. Khan Academy interview. How memory works. I guess not necessarily. I guess he was not. Well, then if you link the video, we can check it out.
This.
I mean, he's clearly not a regular on Computer File, that's for sure, because they live in different places of the world. But yeah, I mean, he clearly knows the guys from Computer File. I mean, he's friends with Ben Eater and with Through Blue One Brown and all these people. And I mean, yeah.
Shift over, and of course, if this chip wasn't powered, which it wasn't, the power was not connected. Uh-oh, this is falling out. Oh boy. Yeah, so if this chip wasn't powered, then its outputs would be floating, and the inputs on these chips default to 1s, and so whenever we do a write, it just writes all 1s. So that explains the behavior that we saw. So now I need to figure out how to find a good place for this ground. Can I get it to reach? Yeah, looks like that'll work. Okay, let's give this a try. So if we power it up, we get some just random stuff in memory there. But with these all zeros, if we write, we get all zeros. So it looks like that might have fixed it. So let's try setting a different pattern in here. And write that. Okay, looks like we write that. And if we switch to address 1, we get some other random garbage. And if we go to all zeros here and write there, then we got all zeros. If we go back to address 0, we should see, yep, we see that pattern that's in address 0, address 1. If we go to address 2, we get random stuff, but we could put in, some other pattern like that. If we go back to address 0, we see that. If we go to address 1, we get 0. So it looks like we are able to put whatever data we want into memory by selecting the address here, selecting the data we want here, and pushing this button here to write that data in that address. So now, if we go to run mode, then we should be now using the memory address register here, and it looks like that's pointed to address 0, and so we're seeing what's in address 0 there. Now in this case, if we want to go to address 1, we've got to kind of set our
thanks, Tristan Bdell, for the Twitch Prime sub. We have also now a new emote, if you want to check it out. So I guess we need 4. And then let's also connect this.
a 1
I have no clue how fast my upload speed is. Does it matter?
on the bus here. So we want to set these top 3 bits to 0, and then of course the bottom bit will default to 1 when we set our read signal here. So this is our read. And actually, let me stop the clock for a second here.
Okay, so I just want to quickly check if that is to what we have connected it right now. So yeah, those are the 4 data pins. All right.
So if we say we want to, well, we'll write, I guess, from the.
Does it look like a bunny? What do you think? It was kind of. I wanted to. I mean, I might still just do a white bunny, but I was thinking it would be kind of cool to have the binary bunny from the old liveoverflow intro. So I tried to make that work, but that's pretty tough with the shape and the individual characters, the 0 and 1s. So I feel like if you know what it is, then it kind of works. But to somebody who doesn't know that it's a bunny, it doesn't seem to look like a bunny. So I'm not so sure about it. But I think for now it's okay because we still have 2 free emote slots, and I have no clue what I should do.
Registers per second. So we're going to write to the bus 1000. So if we set this enabled there, then on the next clock pulse.
Okay, let's try that. Okay, so you can see the address up here. Okay, so this is manual. So this would be now the input from here. And that this is completely 1 right now is a little bit weird because... I don't know. Maybe it's not weird. Okay, wait. That's enable. Oh, wait, the clock is already running, and that was a bit confusing. All right, okay. So input is enabled. Let's change, like, for example, like this. Now the address we should read should be 1000 with the next clock pulse. So we can execute 1 clock by pressing that other button up here. So let's see if when we press that with the next clock cycle, we read that in. Okay, seems to work. We read the 1000, and so we can now put that back and put. Now it should be 00100. Yeah, works. Cool. And then we disable that again.
We get a 1 in our address register. And of course we see the 0 because we have a 0 in that location of memory. If we want to go back to
Looks
address
like
0,
a
then we have to
splooge.
set all 4 of these
Sludge.
bits
Yeah.
low. So let's go ahead and set that 4th bit low. And so this signal is still inputting a write signal. So on the next clock pulse, it should put a 0 into the register here. And that goes to 0, and we see the memory that, or the data that's in that memory location 0. And we can try going to memory address 2, and on the next clock pulse, whoops, oh, I just have these wires mixed up. Let me put these in the right order here so I'm not confused. There we go. So this should be address 2 on the next clock pulse. Yep, puts a 2 there, and then this is the data that we had stored in address location 2. So it looks like the memory address register is working. That's great. Now if we want to read this data from the bus, or read this data and put it on the bus, again, we're going to connect the bus over here, and we can hook up some LEDs just to see for now what's over here. And like I did before, I'm just going to connect 3 of these LEDs just to give us an idea. So if we want to output, well, right now, so we have location 2 in our address register, and if we want to take the data that's in location 2 and put that on the bus, then that's this signal here. We take that low and we see, well, at least the bottom 3 bits, it looks like we're outputting that. And I guess we can move this LED here and see, yeah, that 4th bit is set there, and then the 5th bit should be off, 6th bit should be off, the 7th bit should be on, and the 8th bit should be off. Okay, so it's looks like it's outputting this thing onto the bus when we tell it to, and then when we...
Okay, so let's see if that's also true for us. So this is the output, the bus transceiver. So on command, so this is currently what is like, basically these LEDs show what's the input to this chip, and now basically based on if we enable or disable it, it should output it or not. And so I also have an LED here. So it's plugged it. Okay, so and ground is always enable. So a positive here, positive line is disabled, and now we enable it, and now it's outputting. If we write a 0 into that lowest bit there, now it's as you can see, now it's also 0. Okay, so that works. Now let's, I guess we can quickly basically go through all of this. Let's set the next one also to 0. That also works. Set the next one to 0. Write that also works. Next one to 0 also works. Next one also works. Oh, now we get here a bit. Guess I gotta hold it. No space. Yeah, this looks really good. Yeah, all of them also in the correct order here, exactly like the LEDs. So that also seems to work.
We tell it not to, it doesn't. So then I think the only other thing we want to test is make sure that when we want to take data from the bus and put it into memory, that we can do that. And so in that case, I'm going to take these LEDs out of the way, and I'm going to use these wires here to put a value on the bus. So again, you know, these are going to default high. So I'm just going to set a couple of these. I'm going to set this 2nd bit low, and let's say the 3rd bit low. Maybe the 6th bit low and the 7th bit low. Just those 4 bits I'm going to set low. And then I'm going to use this signal down here, which is our write signal. So, we've got this address 1 in the memory address register, so we see what's in memory location 1 here. We saw that we could output that to the bus. Now we have a different value that we want to input from the bus and store in that memory location. And so if the control logic of the computer wants to do that, then it would set this high to say, I want to write to memory. And then on the next clock pulse, which, I don't know if you can see all of this, I'm going to just pulse the clock.
This is kind of confusing. Most of the chips that are somehow controlled have are enabled on low, and high is always disabled. Now down here, based on the gate that we are using, we are ANDing these together. No, wait, that's a NAND. Right, yeah, because we want output 0. So this control thing is basically later controlled with a high, whatever.
Clock here, and we should see this new data go into memory.
Chris, haven't you been around in multiple streams so far? I feel like I have answered this question every stream. I might add more stuff we don't know yet. It all depends on how much we learn and kind of, yeah. But yeah, flag register or more registers are always an option. I don't know.
And there it is. So that new data is in memory. Oh, something interesting happened here. You see the address changed.
Oh, don't be sorry. I didn't mean to, no, there's no reason to say sorry.
And that's because we're also writing to the memory address register. Normally that would never happen because you wouldn't write to the memory address register.
Okay. Wait.
If you can see all of this, I'm going to just pulse the clock here.
Oh, right, the clock pulse. We forgot that.
And we should see this new data go into memory.
Okay, clock pulse. No, this button doesn't matter. It should only be the clock. Okay, why is this not working? Okay, let's quickly measure if the control, like the yellow right. Wait, we also need to, this has to be disabled. Okay, that's fine. Output, yeah. And the address up here it's fine. Oh, wait. I need to go onto run mode. Now it should work. Yes. Okay, now that worked. And that's also what I said. The first, third, and fifth value I set to low. Okay, so basically the problem that I just had was that with here you can switch between manually inputting stuff, then we have the red LED, or the computer is running and it will output its own stuff through the bus. That's where the green wires we added here were. So this is simulating what the CPU would input itself. And so I was not on green. Still wasn't red on the manual mode, but we needed to go to the other mode. So that also seems great. Let me just check the other 2 bits up there if they are also. Let's set. So here I'm holding the next bit, and theoretically, this one should now turn into a 0, and this should into a 1, I think. Yep. And now the last bit, basically the same. Okay, so all of these are also in the correct order. So this looks all really good. I don't know what the max speed will be. Currently, how fast it can run is 500 hertz. That is determined by the configuration of the clock generation that we have here. What the max speed will actually be, that's something we have to later measure. Oh, cool. Mokiros also wrote something in chat. See the pay to win feature that I've also added. I changed the cheer badge that you get when you cheered, like when you paid money, and now it's like a red bar that is slowly filling up. The more you cheer, the fuller it gets. At least with each bracket that Twitch allows, so it gets quite expensive to make it fill up a bit more.
And there it is. So that new data is in memory. Oh, and something interesting happened here. You see the address changed to all ones, and that's because we're also writing to the memory address register. Normally that would never happen because you wouldn't write to the memory address register and the data at the same time. You'd want to do one or the other. So let me back up a second and turn off the writing the data to memory. Then I want to go back to address 1. Actually, let me just double check here. Address 2. It looks like it wrote it there too. We'll go back. Actually, maybe what would be easier here is we can use this reset signal and just reset to address 0. So we're at address 0, and we want to not write to the address register because we don't want to change the address. We only want to change the contents at that address. So we want to stay on address 0, and then we want to write to that address this data. And so then on the next clock pulse, yes, it writes this data into memory. So I'm reasonably convinced that that this is working now. It's not a total test of every connection, so there might be like one bit that's not hooked up quite right, and we'll probably find that later on when we start hooking everything up together and running more complex programs. We'll see some subtle issues, which are always fun to troubleshoot, but at least at a quick sort of test, it looks like everything is working more or less the way that we want. One other thing I'm going to do, just as kind of a convenience thing, is we've got all these little control signals everywhere. I'm going to label them just to make life a little bit easier for me. So if we go up to the clock, this signal here is the halt signal. So I'm just going to stick a little label there that says this is halt, which halts the clock. This is the memory address register in signal. So when this goes low, we're going to input a value into the memory address register. So I'm going to call that MI for memory address register in. And I've got the bar there because it's a active low, so normally we want that high. This is the RAM out signal. So when this goes low, this is an active low. When this goes low, it outputs the contents of RAM to the bus. So mark that as RO for RAM out. And that's active low, so we'll keep that high normally. And then, of course, to input from the bus to RAM, we've got the RAM in signal down here. So I'll mark that as RI for RAM in. And that's active high, so I don't have the bar there. So normally that will be low, unless we're inputting from RAM. And then while we're here, since we've got the instruction register down here, I'll label those as well. This is the instruction register out. So this will output whatever's in the instruction register to the bus.
We should also build the instruction register.
So that's the IO, and that's an active low, so normally that'll be high, unless we're outputting the contents of the instruction register to the bus. And finally, the instruction register in. So this will input data from the bus and store it in the instruction register. And that's also active low, so that's II, and normally that'll be high. And there's actually one last thing that I want to do, which is For the RAM in, when we're writing data from the bus into RAM, which you'll notice if we set this high, so we're RAM in, when the clock signal goes high, you see that this is all zeros. And that's because when the clock signal is high, we're writing for the entire duration of the clock signal high. Really, what we want to do is write just on the leading edge of the clock. So right now we're NANDing the clock and the RAM in signal. Oops, you can't quite see that. We're NANDing the clock and the RAM in signal. So this white pin 1 here is the clock, and this is the RAM in signal. But really what we want to do is we want to look at the RAM in signal and just the leading edge of the clock, and just at that moment where the clock goes high, not the entire time that it's high, we want to actually, that's the moment that we want to read data from the bus and put it into RAM here. So we can do a really simple edge detector circuit by pulling this pin low, and then instead of inputting the clock directly into that pin, if we go through a capacitor, then what will happen is this will only be high for the time it takes the capacitor to charge through this resistor, right? Because the clock will go high, so we'll get 5 volts over here. And then, of course, we've got 0 volts, we've got ground here, and so this will charge through the capacitor. And while it's charging, this pin will be high, but as soon as the capacitor charges, current will stop flowing through the capacitor, and this will go low again. So it'll only be high for sort of that moment that it takes for the capacitor to charge. So this is a 0.01 microfarad capacitor, and this is a 1K resistor. So a 0.01 microfarad capacitor and a 1K ohm resistor. And so if we want to know the time it takes for this to charge, we just multiply these together. But first we've got to get it into standard units. So 0.01 microfarads in standard units, which would be farads, would be 0.000000001 farads times, and then 1 kilo ohm is 1,000 ohms. And if we multiply these two together, basically we're just moving the decimal point over 3 here. So we get 0.00001, and then the answer will be in seconds. And that'll be the time that it takes for the capacitor to charge. And so in other words, 0.0001 seconds is going to be 10 microseconds. So basically, the write signal here that ends up going to the 74LS189s, our actual RAM chips, in this scenario is only going to be 10 microseconds. So it's just going to be for an instant, it's going to write whatever is on the bus in that instant when the clock goes high, which is exactly the moment that we want to register that. So we can kind of test this out now. So right now we have this value in the bus. If we just change one of these bits to something else, we've got our RAM in, oops, can't quite see, we've got our RAM in signal high here. So on the next clock cycle, it should write that value in here. We'll just change this bit here to high. And so on that clock signal, you see it goes high. And it doesn't matter how long that clock signal is, it's just the first 10 microseconds of the clock that it's using to clock in that new value. And so if we change this value on the bus, new clock, doesn't matter how long that clock signal is, it's the first 10 microseconds that clocks in that value. So now we have a little bit of an edge detector here as well. So that pretty much should do it. This here is our RAM module. I think we've pretty much got everything working, at least the first initial tests that we can do here. So I think in the next videos, we'll either work on the program counter, which is a fairly simple circuit, or I think I'll do that first, and then I'll get into the actual output register, which is kind of interesting because we're going to do a binary to decimal converter.
Cool. I wanted to pause before it goes to the next video. All right. Okay, so how much for the 0.01 microfarad? How much nanofarad is that again? 10? Micro to 0.01 nano to And what was it, Pico? Yeah, 10. I'm really good at math. What's that, Nano? Yeah. Okay. So this is the capacitor that we can use. Oh, thanks for the tier 1 sub, Andromeda. We I need to I need to be faster with that. Okay, so we got that, and I have a 1K resistor here as well. And so I kind of want to look at this with the oscilloscope in a second too. I think that would be kind of cool to look at. And damn you, Ben, I measured the length of all these wires here, and now you move them over one. Now everything is kind of screwed up. Let's turn it off because we moved the clock signal over here now. Now it's all crooked. Ben, why did you do that? Into ground. How is this allowed on Twitch? This is TOS. So far we are still at 0 wires, so we are not breaking the TOS right now. And I guess we can shorten those legs here as well. Imagine a terrorism category on Twitch. Okay, let's see if it still works. What I just did here. So we this is still high. This is now on. Okay, there's something else stored in there, but now with the next clock pulse, it should read. Didn't work. Okay. This is disabled. No, let's enable it to read. Doesn't work. Oh wait, we have to go to run mode. Okay. No, I got it. Oh, this was connected wrong. Ooh. Nothing got hot. Okay, wait. Why does it not read anymore? Am I just using it wrong? Wait, we are in green mode, so that's the run mode. We need to disable reading so that it can output. Now it works. Okay, correct. Okay, yeah. So that seems to work. Okay, so I want to quickly look at that rising and falling edge immediately again with the oscilloscope. I think that would be kind of cool. Wait, I need to plug in the other plug. I mean, if you are not careful with the capacitors, then maybe it would be a little beam. Okay, I can turn that on. And then we can, come on. So I would say let's connect one to the regular, just the clock cycle itself, and the output. So clock would come in here, and then we connect another one to the signal that is actually given to that thing. Right, so it's waiting. Let's switch here. Let's increase the clock speed. Channel 2 enable. There we go. Okay, wow. There's a lot of noise on that signal there. Isn't it kind of weirdly oscillating between the amount of noise? Okay, well, whatever. If we zoom in, so the blue one is blue one is the regular clock right now. So if we zoom out, we can see that the clock is currently running with 10 hertz. I believe. Let's see. Let's measure on channel 2, I guess. Yeah. So the clock is right now running on 10 hertz. So the blinking you see there is 10 hertz. And now if we zoom in and look at the yellow one, we want to trigger on, wow, are we not triggering on, wait, what is going on with the trigger? Aren't you supposed to trigger on the rising edge of, oh, the trigger was in a very weird place. There we go. Okay. So, as you can see, like blue stays high for a long time. That's a clock signal. But the actual, like the edge detection basically is just a short pause here at the start and immediately drops down again. You basically cannot even see this edge anymore if you zoom out enough to see this individual clock cycle. So it creates a really short pulse. Cool. Can we see how long this pulse is? So right now the time division is 20 microseconds. So each box here, can you see this? Kinda. So it's basically like 20 microseconds long. SL Midnight, we basically finished the RAM module, and we just watched the testing and troubleshooting video by Ben Eater, but basically the RAM is now done. We were just verifying that everything works, and specifically what we are looking at on the oscilloscope right now is we changed like the control signal that is coming in to the RAM, so that it does something on the rising edge of the clock. We added here just a tiny little circuit here that turns the long clock signal into just a single pulse, and so we were just looking at that in the thing. If I can show you here. So basically here, this chip is a NAND. It combines the clock with the control signal if the RAM should, what was it? Yeah, read or write onto the bus basically. But we don't want it to be basically doing that for the whole entire time of the cycle. We only want it to react on the rising edge. So we added this little capacitor with like a resistor there, and that creates just this very short peak, and then I don't know. I'm really curious about that extreme noise on the power line though. That's like really a lot. Isn't that a lot? And it's not consistent, so is that, what could be that interference? It's also not 60 hertz because when we go out, so we have a 10 hertz right now interval. So basically we would, if we zoom out like that, we should clearly see the 60 hertz. Maybe it is 60 hertz. No, I don't think so. Oh wait, 2, 4, 5, 6. Could be right. Sure, it's not 60 hertz. well, so right now the clock signal, so the blue thing is running with 10 hertz. So a 60 hertz signal would be 6 of the blue ones. And if you look very closely, let me remove the Canon thing again, you see it like thicker here and then thinner here. And these are always like roughly 6. So it's like 1, 2, 3, 4, 5, 6, and then it goes like low again, roughly. So that seems like a 60 hertz noise, doesn't it? Let me just put both of these just to VCC. Then we should be able to look at, let me bring the trigger down to here. Oh yeah, right. It's 5. It's plus 5 volt. It's all the way up there. Okay, just on the power line, I don't see it now. So now it's just like on the 5 volt connected, like nothing is doing it, and you don't see anything there. So it's only on like the clock output and yeah, well, whatever. Okay, cool. Cool. So I guess we should now build the instruction register, right? Ben already has it. We don't have it yet. Before we move on, we should, I guess, catch up with where he's at. So I guess we could do that. And to do that, we need at least a breadboard. Which we connect here. So we remove that one. Remove that side here. All right. Am I a complete idiot? Why did I do that? There was already a breadboard. Oh. It's time to end the stream. Okay, so we want to build the, let's see, does he have the instruction register? A, B, okay, so the instruction register is displayed here. So from the parts, somebody said it's slightly different, but what is different? I guess here is something going to ground. Okay, it's very similar, but a little bit different. Sorry, looking on the website, this is the schematic for the instruction register. Put F in chat for Daniga. When you're done with the project, are you going to print it onto a circuit board? That's one of the things that we could do, but it might be a fun project, but I don't know yet. Don't plan so far ahead. We go with the flow, whatever seems fun. So we want a 245 and 2173. 173. And 173. Oh no. I just realized I didn't take my allergy pills today. 245, 173. We need instruction register is explained in that video. Did I miss that video or?
This, and then we also need
Huh. What is he saying there?
to build an instruction register, which is very similar. There's a couple differences with it. One is I've just basically built it the opposite direction, and that's just because physically the way that we're going to lay out all of the boards,
Morose,
we're going to put the bus in the middle, and it's just easier if the 74LS245 chip, this buffer chip, is towards the middle of the board. And so these are going to be on the right side, this is going to be on the left side, and so just having this kind of reversed is a little bit easier. And so you can see these are basically, you know, if you look at the A and the B registers that we built here, they're mirror images of the instruction register, which is this board down here. Otherwise, it's pretty much identical, except for one other change, which is that the most significant 4 bits, so these top 4 bits, are a little bit different in that they are not output back onto the bus. And so you'll see here, there's only 4 green wires, so only the least significant green wires are connected to the LS245. And so if we look back here, that's just, you know, these 4 wires for the most significant bit, they just aren't connected. And the reason for that is that rather than being output back to the bus, they're going to go into the instruction decoder, and we'll get into that in future videos. But for the instruction register, only 4 of the bits are going to be output when we enable it. But otherwise it's pretty much the same. And so again, we can hook this up as well. So we've got the power here. I can hook that over to the power for everything else. And so that's that. And then of course I can hook the bus up to our common bus here.
And how did I miss this? Did we just like, I don't know, ignore that? Thanks, Morozo. Okay, awesome. So let's build that. I guess we can use one here. These are the register that we have built, haven't used in a while, as kind of like a reference. Oh, oscilloscope is gone. Yeah, we are done with the oscilloscope part. You clicked for the scope. Oh well, here, look at it. Tell me when you've seen enough scope. Okay, we need LEDs. Blue and yellow ones, I guess. By the way, I also wanted to do a small modification with the red LED here, tell you in a second about that. And then we need just wires, but blue is running very low, so we need to open here the second pack. Get some blue here. And I guess we do it in the same color actually as these ones here. So we might also want the green one here. And then I guess we need all colors for clock and everything. That's enough. Glad I could satisfy you. That's it. Okay, so okay, so I have to say, I sorted everything now, right? So it was super easy to find these parts. And somehow I feel like I found them too fast. I feel like there was something about just digging in a pile in a box where you dumped everything in, and it takes time, it stretches everything longer, it creates content for the stream. And now that everything is sorted, I just find it, and now I'm left with, well, crap. Now I don't know what else like to fill time with. How much did this cost? Did what cost? Yeah, I spent actually a lot more than this since I started because I did another order. We tested out different LEDs. We tested out different buttons. We tested out different potentiometers. So that cost more. I bought a few parts more often. I had to get more of these wires because they were running low. So I spent a bit more than that. Yeah. And then also, if you would start from zero without any equipment, you would also need to buy multimeter and maybe a power source even. So it kind of adds all up. But I have to say, it's not a lot. I always see this in comparison with other stuff, right? Like if I buy a Lego, let's go here for like a nice Lego. Bring me to shop. Yeah, Lego is expensive as fuck, but it's like you get less playtime out of. Well, depends on. Yeah. Like a nice Lego costs also 200, 300 euros. A nice big Lego that gives you a lot of time to build. Okay, well. Yeah. What I'm saying is a computer game costs like $50, $60. So that's a couple of computer games, but I don't know. It's just different form of entertainment. It's just painted plastic. You should talk to some Lego fans. They would be more happy if they get more painted Lego parts instead of stickers. I doubt that you can print nice ones with the 3D printer, and I would actually doubt that that would be really cost efficient. So first of all, I think they would be so low quality they would kind of suck to build with, and second of all, they would probably be not as cost efficient as you imagine it to be. Well, but you would have a 3D printer. Yeah, I don't know. What does a good 3D printer cost? By the way, is anybody of you into 3D printers and can recommend me a lazy one? You know, like one that I don't need to maintain, and it's not necessarily on the price, just like a thing that kind of works when I need it to work. Okay. By the way, I also wanted to replace this LED up here. This LED tells us what mode we are in. If it's like our hand selection clock. So so right now it's like the regular one, and then we can switch. Now it's our hand clock. And so I feel like we should put that color here the same as here, this one here. Because here we said red is our like from hand mode, while green is it's all running and kind of like turned on basically. So I feel like I want to turn that, I guess it's on when it's in running mode. So I feel like I want to replace it with a green LED, just so that, I don't know, because I constantly keep forgetting which LED shows me what, and I feel like if I make that green, it makes more sense. You can print scale Lego pieces. Who wants to play with Duplo? I want to play Lego. And by the way, it's just a matter of time until I spend money on a very expensive Lego piece and we build it on stream. I kind of want to buy that lunar module. That's kind of cool. And it's actually not that expensive either. Prusa MK3. Do you speak from experience or? Have no clue about 3D printing, but since it's a printer, it will naturally break whenever you need it. Yeah, so, crap, where was that attached to? Oh, crap. I guess this here. All right, yeah. Cool. So when the 3D printer craze kind of started in our hackerspace, obviously people started also to build one, and so we were like pooling money together to buy the individual parts. And it was like one of these 3D printers. It might have been, isn't it Prusa, that one that you like kind of like where it's kind of like self-replicating, you can print its own parts, like open source or something. So we were like buying these parts and we were reprinting the parts, and you have to calibrate it and get everything like correct with like how like the heating plate and all that stuff. And so it always like worked for a bit, and then people just printed stupid stuff all the time, and then people stopped using it, and then like a week or month later somebody wanted to use it, and then it was like not calibrated anymore, and it wasn't really working anymore, and then parts were broken, and suddenly you needed to replace the parts. So it felt like every time you wanted to use it, there was significant repair cost and time that you needed. You have a Prusa MK2S at work and it's a beauty. What do you work? Wow, that is a big block. Oh, sorry. A lot of 3D printers are clones of the Prusa. Yeah, but was Prusa like the original kind of thing that you could build yourself, basically? I'm not so sure. Ender 3 Pro. I'm not necessarily looking for the cheapest offer. I'm looking for a reliable thing that's not like, okay, not killing my bank, but you know, it's. I guess my budget is under 1,000. I think for a 3D print. I feel like under 1,000 I would be. I would be okay. I guess that's my budget. Like $300 seems so cheap that I feel like that sounds more like that breaks easily. I would be more inclined, for example, to buy this one here just because I feel like, or I would hope that this holds up a bit better. Yeah, if it, okay, don't buy an Ender if you don't want to maintain it. Okay, yeah, that's kind of how I would feel about it. What are these ones? SL1? Why are they in the glass shield like that? Do they work like with lasers or something? UV LED. Ah, yeah, okay. Is that like with like a bath? Thin layers of resin. Oh, that's kind of. Isn't that cool? Isn't that not cooler as a 3D printer? Does anybody like really know? Is that not cooler if you build like with resin? Can that not make cooler stuff? Hurry, offer ends. Damn. Buying machinery with no intention of maintaining it. Yes, and that's what I hope. I pay a little bit more, and then I don't need to maintain it. What's the difference here? MK3S. Is that just it's not assembled? You need to assemble it yourself. Is that the price difference? Resin gets a lot finer details, but it's not. Yeah, that's what I imagine. Pay someone to maintain it for you. See, the problem is there's the word someone in there, which means another person, and I don't like to deal with people. Resin is nasty and brittle. Yeah, I guess this is with the bath, right? Like you need to somehow clean that or deal with those fluids and those chemicals. I guess it requires some kind of maintenance from that sense. Most people don't want to maintain their car either. True. And luckily there are just a lot of shops you just roll in and give them money and they do stuff. I don't think this exists for 3D printers. It's toxic, you have to wear gloves. Yeah, okay, that sounds kind of annoying. I mean, I don't even know what I would do with a 3D printer. I have absolutely zero use for it. It would really just be... it's kind of, it would just fulfill my dream of getting like a home lab with all the different equipments, like a hackerspace in your home, and you don't use any of the tools, but you just want to have them around you. That's kind of the deal for me. Can't wait for 3D printers that run on water. You mean like a mill? Like you have a water wheel and that generates power for the printing? Yeah, and then you could also just like online order your 3D prints. If you use it that rarely, then it also doesn't make sense to have it yourself. True. And then also you could probably get super nice quality prints. Okay. Once you own a 3D printer, you will find a use for it. I don't know. I really have no clue what I would use it for. As soon as you have one available, you start to print every small plastic parts around the house. For what? That's kind of what I thought when I bought a lot of what's it called? Damn, what is it stuff called? Sugru? The stuff that you form, it gets hard and you can use it to repair stuff. I bought a lot of that stuff because I thought, oh my gosh, it will be so handy to fix all the stuff and use it. And then we used it like once or so. A week ago, you needed a phone holder instead of buying on Amazon when you print one. See, there I would be lazier. I would just buy it on Amazon and would be there the next day. Before that, I might even check Amazon Prime Now and see if there's an okay one available Amazon right now, and then they would deliver it in a couple of like 2 hours or so. As soon as you have an oscilloscope, you will find use for it. Exactly, you buy it and then you use it like 4 times and then you don't use it for 2 years. Anyway. Where is the website? There we go. Amazon will deliver faster than the printer will print the part. Yeah, I think so too. And it will look better. Maybe. I would print stuff for your crazy camera rig. But that's the thing. A camera rig needs to always hold stuff. And that stuff is not like strong and rigid enough. Like all these little things I have there need to hold quite a lot. Yeah, a CNC machine would be cool. Like a laser cutter would be also cool. What DSLR do you have? I have one DSLR. This is here a Canon 80D, and then I have a mirrorless Sony a7 III over there. Yeah, but I have no clue about cameras. I just bought this camera. Well, first I bought this camera because I want to use it for streaming. But the Canon suck for continuous video stuff. So the screen you see at the top up there, that is from the Canon here, with the macro lens, and it looks nice, but it's like connected via USB, and you need like a software to get that, and it kind of sucks. And so I looked around what other streamers are using, and I saw Slightly Musical, who has like an awesome setup, and he uses the A7 III, and so I bought the A7 III, and that one is cool. And now I'm contemplating to buy another one for the top-down shot, because like this Logitech, you know, the standard Logitech webcam just doesn't look so nice. And it would also be cool to have like a zoom lens to then like zoom in a little bit. That would be kind of cool, I think. Yeah, I mean, I really don't use it to its potential. It kind of feels bad that I paid that much money for it. It's literally just a glorified webcam at this point. I set it up once. I don't know how to use it. Yeah, but it looks nice. I think it looks really nice. Like I think that image looks really good. Is it cold in Germany? Why are you wearing a hoodie? It's cold in here because I have an AC. Yeah. And then also, like, I mean, the Canon kind of sucks with the connection, as I said, but the Canon also looks like these macro shots. Doesn't this look awesome? Mr. OneDev, how can you code this computer? You literally write by hand. Here you can select the address you want to write the value to, and here you can select the value you want to write to, and then you write your program instruction by instruction into the RAM, and then you let it execute. It's actually not that cranked up so much. It's like, wait, how warm is it in here? It's probably almost like 30 degrees in here anyway. The second reason why I'm wearing a hoodie is because I was shopping yesterday. And I bought that yellow hoodie. Oh, fuck, what is streaming doing to me? God damn it. Where's mine? You have been considering buying an A7 III, but they are so much. Yeah, they are really expensive. That's why I'm also not sure about buying a second one, because do I really need that overhead shot? Like, I don't make any money. Like, I make the money I make from YouTube and Twitch does not justify spending that money on a camera. That's why I probably shouldn't. It's 28 degrees in here, so it's colder outside. Wait, let me open my window. It's not working. Like parts of it are working. We are still working on the individual parts. Okay, so let's go to this screen. No, wait. Actually, we could stay on here and have that up there, and then you can see me building there, because we are now working on here. So now you're running your AC while having the window open. That is actually correct. Let me turn that AC off. Now, buddy, what you doing out there? Can you use an Arduino with it, or is that cheating? It's kind of cheating, obviously. Depends on what you use the Arduino for. For example, for programming the program with an Arduino, I think that's fair, because otherwise you would put it in by hand. Let the Arduino do that for you. Anyway, we need to make progress here. Let's get going. Okay, so we need to connect. I guess we start with the 245. We connect the. Yeah, let's open the 245 sheet. Um, 245. So let's first deal with the power connection, VCC and GND. So there would be, all right. There's this Sony lens that everybody's using for the A7 III. It's a zoom lens, and it costs like almost as much as the camera itself. It's like 1,800 euros or so. And I really want it, but it's just. And but yeah, I didn't. It wasn't justifiable yet because I don't use this camera besides connected here, so I don't really need that. This is stationary, it's fine like that. Love the Sigma lens. Yeah, I think there's also a Sigma lens that everybody's using, but that is like this cropped sensor Sigma lens that a lot of people still use on the A7 III. But it's kind of like the cheaper choice if you don't want to go all the way to that other lens, which I forgot the specs of. How does CPU differentiate instructions from just raw data? That's a really good question. Let's wait with answering that when the computer is set up more. Because I think it will questions. This is the kind of questions I ask myself also when I was younger. Like, how does a CPU? It's all zeros and ones, but why are some zeros and ones mean it's doing something and some it's not? Like, what is the meaning behind it? That would be that's something cool to explore, I guess. And yeah, Morozil, that's a good answer. It doesn't. That's how buffer overflows work. No, at least on our architecture that we have on our, like the typical Intel CPU, x86 CPUs that we are running, data and code is shared. There's no it's not living in different areas. We have one RAM, and that RAM will contain code, but it will also contain just other stuff that we want to use the RAM for. And if we are not careful, we might have a bug, and suddenly it tries to execute the data in our RAM, which we didn't intend to be instructions. And that's what you basically do with like the old school buffer overflows with shell code. And the A7 III. A173. So that one has also. And registers are just like, registers just hold, a single value. A register is just like a variable that can hold one single value that then the CPU can use that register for various things. So an instruction is not really ever stored in a register. You have an instruction register, but that just just contains the address of the next instruction. It never contains like the instruction or something itself. It just is a register, and that's the register we are building right now. That register will just contain the address of the next instruction that will be executed. So that will just be a memory address. And we hope that address we have an actual valid instruction stored, because otherwise yeah, it could also accidentally point into data, and then the CPU would try to execute data as code. And I mean, like on modern CPUs and modern programs, we do separate data and code more. Modern CPUs support this concept of different memory areas that are that are not executable, and areas that are specifically executable but not writable. That's kind of a mitigation against like these old school buffer overflows. But so then you have kind of a separation. Then you have memory areas that are dedicated for executing code and you can't modify it, and you have areas that are dedicated for data and you could never execute them. So if you would set your instruction pointer to such an address, then the CPU would probably get a segfault because it would see that, oh wait, this address is in a memory area that is marked as not executable, so I refuse to execute it. Modern 64-bit CPUs work the same way as this 8-bit. You need to be more specific because the answer is clearly a no, but also clearly a yes. Okay, next one. That's the thing what Isar Eagle is saying. Principally, yes. Like, you have different registers, you have a clock, you have memory that is somehow accessed, you have an instruction decoder, you have an ALU. Like, all these principles, these concepts are somewhat the same, but obviously modern CPUs have way more crazy features. Really, really crazy how it's implemented, pipelining, and a lot of fancy stuff. And by that sense, it's like not even comparable to this computer. But on an abstract level, they are still the same. You need to learn something like this by doing. Like you can't. I mean, in theory, you could just read the Intel x86 manual, right? You could just read this document here. It's just a 25 megabyte PDF. It only has it's lagging. It only has 4,900 pages. I guess, wait, that's unfair. That's just the reference here at the end. So it only has like, I don't know, what is that? 4,800 pages that you could read about all the various instructions. Yeah, so you could theoretically read that, but that doesn't make any sense. You could maybe read the beginning here where it talks a bit more generally about the architecture, some kind of like kind of a little bit how stuff works. But this is a reference manual. You just don't read that stuff. Like, you learn that by doing. Like, you want to write shell code, and now you want to understand, hey, what does this instruction do? And then you look up, okay, what is syscall actually for an instruction? How are syscalls implemented? And then you like here you go to that thing, and then you see, okay, a syscall is opcode 0f05. It does a fast call to privilege level, whatever that means. It's 64-bit mode, and then there's a description. Invokes an operating system call at privilege level 0. It does so by loading RIP from this MSR register, and all that kind of stuff, right? And then and now you learned about it. Reading all of this is worth to put on your resume. I feel like nobody would hire you. They would think you're insane. The bad thing about x86 is that they added way too many instructions that nobody uses. Like what? Like what are these kind of instructions you're talking about? And all instructions use power. What do you mean by that? Yeah, I heard that that Microsoft doesn't keep a compatible syscall layer. They want you to use the wrappers, which is fine. Doesn't really matter, does it? But all have an instruction set, pointer, and counter. I don't understand your question. Some people just really love to read, though. Yeah, sure. But then you just keep it secret, you know? It's like reading 50 Shades of Grey. You don't tell anybody about it. You just, you do that alone at home in a dark room. Okay, next cables. So the 245, we connect A0 to A3 to ground. So A1, wait, this starts at A1. So pin 2, 3, 4, and 5. Okay, we connect that to ground. You tell everybody about it just for the weird looks. So when I was in my bachelor's and I was working at a company, like doing internship, my mentor there told me about his colleague that they went to like some kind of like conference, developer conference, and they do like real low level implementation. So they worked on like firmware and also kernel hypervisor stuff for like the mainframes and things like that. So really, really extremely low level programming, and so they know their way around like the CPUs and the architecture. And then they were at this conference, and there was this programming competition where they had to like speed up a piece of code. They had to make it fast, and it was like some kind of matrix multiplication or so. And the team that could run the fastest program, they would win like a laptop or something. So it was like a booth or like part of it was just a small challenge at that conference, I guess. And my mentor told me that his colleague won it, not because he optimized the algorithm like everybody was doing. He just knew the CPU better and the caching and how it all works. So he just rearranged the data, basically like flipped the matrix, like just transposed the matrix, basically rotated it by 90 degrees, and then did all just the algorithm that was already there, and that just killed, was faster than anybody else. And I was super baffled how anybody could like know so much about CPUs that they would like understand that if they just handle the data slightly differently, that their code would be their code that has to rely a lot on like dealing with data would be so much faster. I don't know if I got the details right. At this point, it's like he told me that he told somebody. Thanks, Linksec, for the tier 1 sub. So we added 4 more wires. The clock runs into every gate, and what really uses power is fast switching of the gates. Unless you disconnect the hardware for these instructions, they use power. Every hardware implementation of the instruction. I don't know much about CPUs, but I would say that's not true. I don't like modern CPUs only consume, they use like CMOS or whatever, and then so they only consume power when they are switching. So the circuit parts that are not used are basically not consuming any power. And on top of that, the CPU manufacturer, especially for the mobile CPUs, they have like huge investments into making it power efficient. Otherwise, they couldn't be competitive. So they probably do like crazy stuff about disabling certain areas of the CPU when they are not used as much as possible, and I don't know what. Oh, it's Uling. Now I connect the names. You want to take university course, supercomputer cluster and GPU programming, where stuff like that was a topic. Unfortunately, we were only 2 people, and the professor asked us if we would take another course. Oh, that's a bummer. And I guess then there's also the whole microcode stuff. Yeah, I have no damn clue. It's also a thing, like, as a CPU manufacturer, you don't really know what exactly will be used later, right? You have an idea for new instructions that could maybe solve like a nice problem, and you implement them, and then practically it's turns out to not be that relevant or not relevant anymore or whatever. So of course, like, some instructions are kind of like bad choices. It's like any product you bring on the market. Some products just really help and others don't. I don't know. They do clock gating first to just prevent it from switching, then power gating of certain areas to turn them completely. Turning stuff back on takes longer, so they transition into a higher sleep state only if they deem it necessary. Yeah, I know there's some crazy stuff going on. All of that on different areas on the chip. What music do you enjoy? I don't have a particular. It depends on my mood. Okay. Then we connect. Okay, so now we just need to make sure this side. Oh, wait. Which one did Ben either connect to ground? Wait, I am such an idiot. Wow. No, wait. Okay, wait. No, wait. Yeah, I'm an idiot. Not these. This chip has the stuff pulled to ground. That's the 245. There we go. Okay, and then the next four, where does Ben connect these? Ben connects them to the first chip there. All right, then let's do that too. And I guess we use. Now, what color are we using? I guess green, because it's a register and we used green for the register already. We need a doggo as a sub emote. Yeah, that's a good idea. I need to. I'm not sure how I would make that though. I don't know. Maybe I should just try. YT cracker. Yeah, it's funny that you say metal. Metal is probably the one of the genres that I just have a really hard time to get into. Of course, there are a couple of metal songs I really like too, but that is probably one of the genres I like the least amount of stuff from. Metal is your life. Yeah, I mean, I find it so fascinating, right? Like, I know how passionate people, but I mean, that goes with a lot of different things, but it also happens in particular with, for example, music, that people are so passionate about certain genres, and I just, like, I know that they love it, but I cannot even really understand what they like about it. Okay, so this goes to 173 to the Q input, so this goes to the third pin. But generally, music also doesn't play a huge role in my life. Like I said, it always depends on the mood, what I listen to. So you would have to ask me, like, in that situation, what would you like to listen to? That's more something I guess I could have an answer on. Music is a huge thing in your life? Symphonic metal, I enjoy the way the instrument sounds, but screaming is something. Yeah, so that's also, I guess, something I could relate to. Like the the loud, like the aggressive screaming voice. I guess I can see why people like it. It's might be very, I don't know, in some way stress relieving, I guess, or it pumps you up. But to me, it never had that kind of. I never had that kind of feeling or response to it. I know, but I do really like melody. So the metal songs I do like are also, I guess, more melodic. I don't know. Screaming is the best part. It feels like such an acquired taste. I feel like there is something about the screaming in metal that I just cannot appreciate because I don't know. I haven't acquired the taste yet, and my life would be better if I would if I would develop that taste. Does that make sense somehow? I every time when I hear people talking about metal, also classical music is the other genre I listen not really to, but it's also the one that I have a hard time getting into. But I feel like I'm missing out on something. If you ever see me, you will understand what I mean. Should I just picture like a stereotypical metal fan? Do you have long hair and a beard, and you wear black band T-shirts or festival T-shirts? No, this is not for class. This is just for fun. For fun and education. Learning something. Oh, Zoding. Thanks for the raid. How was your stream today? One day I will stream before you and I will be able to host the raid you. I feel so leeching of you. You should host or raid some other people sometime. You are a total nerd in real life, so music doesn't fit my looks. I know a lot of nerds that are into metal. I don't know, that totally fits my imagination too. We are building an 8-bit computer. We follow like a video series. It's not like I would have come up with this. I'm just like, we are just following instructions like Legos. And now we are building the instruction register right now. And so I need to look up what we need to connect next. Okay, so we connected that. I guess we can connect we need to, what is that, the output enable? Yeah, M and N, so we need to connect these and to ground as well, so let's do that next. Oops. Demonetized. Music claimed. I have a applied computer science degree, a bachelor's. Wire speed police here. Yeah. I need to be careful with the terms of service. Rammstein made you want to learn German? I am tired today. I had to adjust my sleep schedule, so I stayed up as long as I could yesterday, which was basically 8 p.m. and then I went to bed, and so I got up really early this morning because obviously I can't like sleep 12 hours. So it's like getting pretty late for me. I never said I wasn't in super bad. What are you saying? Uses instructions. The Intel architecture lists 8 different length knob instructions. My first reaction to that is I don't know, but I would guess that has absolute. So either it has use for aligning code and getting like kind of like instruction fetching and caching and all that stuff optimized. If so, it's something that a compiler might use to optimize stuff, I could imagine. Or they kind of come for free because the instruction decoder in a way like just works like that, in a way how it's implemented. So, you know, maybe there are 2 bits in an, I don't know the opcode format exactly, but I could imagine that maybe 2 bits kind of decide the length of the instruction that is coming. And so if it's then a knob and these bits decide how long it is, you know, it's the same way. Do you count every possible move instruction with all the possible addresses that are possible? Are these all individual instructions or not? Clearly not. It's like one move instruct. I mean, there are, I guess, multiple variants of it, but let's say there's move and an address. You know, like it's just a move instruction and the address is variable. So maybe, you know, I don't know. I wouldn't say that they are useless. I would assume an exchange on EAX doesn't throw away any high bits. It would just exchange EAX, I believe. But yeah, I don't know. Yeah, I don't know. There could be weird stuff like that involved too. You know, the crazy thing I just thought of, 2 years ago I found your YouTube channel, and now 2 years later, and I just over a month, I will get my first security. Oh, that's awesome. Congrats. RX is AX plus. Yeah, I understand that they are part of each other, but the thing is, a lot of the instructions that just operate on AIX just operate on the AIX part, and they just leave the whole RAX, you know, just leave it be. They don't do anything to it. But I mean, maybe that particular instruction has an effect. I don't know. I might also need a Michael Cera emote. That might also make sense. Maybe I should do a Michael Cera emote. What's the most common vulnerability you find when doing pen testing? So I do mostly code audits on web applications. So obviously the most stuff I see is web application issues. And the most stuff I see there, I don't do statistics on it, so I'm not so sure. But I would say probably like XSS, I guess, or CSRF. I guess some stuff about that. Or maybe just some logical stuff. I don't know. Do you think the metric, what kind of vulnerabilities happen the most, is a useful metric? And if it's useful, for what is it useful? I feel like it's mostly unnecessary to talk about. I think it only makes sense in the context of mitigations, because if a certain mitigations can squash a couple of different bug classes that happen a lot, then that makes sense. But anything besides that, I feel like the amount, like the occurrence, how often a certain vulnerability kind of occurs, is completely meaningless. We added, I guess, 4 more wires. The social account in the background, it's called LaMetric. It's just like an overpriced LED display. Hey, oh, by the way, we talked about it on a stream. I forgot to mention. We talked about this LaMetric, how it's like overpriced and that there are no competing products, and that's why it's so expensive. But I did find on Amazon, I stumbled over, because we talked about it, and obviously Google is always listening, and then it displays different Amazon stuff suddenly for me. I found these products here. From Divoom or so. They are just 40 euros. They are like 16 by 16 LED displays, and they look like kind of the same LEDs. I don't know how they look in person, if they also look as sleek, but I figured I should maybe buy one and check it out. That's like, you could get a couple of them for the price of one LaMetric, so kind of cool. Okay, so we connected those wires. So what's next? We could connect the output, or enable this other VCC connection here. $200 doesn't feel worth it. Yeah, we talked about this on stream before. Yes, it's expensive. You have to consider this product. It was a Kickstarter. You know, it's a small company that made that. If you consider how many they like, it's like not a China mass-produced kind of product that benefits from, you know, being a mass consumer product. It looks pretty sleek. It has a nice software. It has like apps. It has some features to it. It's just, you know, I feel like if you really break down the cost and think about all the people you have to pay for your small company, and I don't know, it doesn't feel like so crazy, to be honest. In comparison to other consumer products, what you can get for 200 euros, you can get like, you know, almost a nice smartphone for that price. That obviously seems crazy, but you just can't compare these things. This is just like different consumer levels. They knew YouTubers would buy them. They priced at the time. I don't think that was the. I don't think that they were thinking YouTubers would buy them. You also have to think how few YouTubers there are. If you price for YouTubers like that, is like, I don't know. That seems like, I don't know. Doesn't seem to be the smartest strategy. Strategy. I keep making that too short. In my opinion, many things just seem overpriced because we see mass fabricated devices everywhere. Yep, exactly. I also think the same with like, for example, services that people provide, like hairdresser, right? Like it's a rush to the bottom that we pay like extremely little to like hairdressers. We want to get like a man haircut for like 10 euros. And so we expect to be able, in these 10 euros included, is not only the half hour that it takes to cut your hair, but the price of the whole place, the tools, and the times where there are no customers. And you think like 10 euros is a sustainable, like, kind of, that's insane. Hi, Tanscon. Yeah, and even 20 euro, like, for example, so I hate going to the hairdresser. So I always try to find somebody who comes to me, who makes like home visits for haircuts. And of course, these services exist. For example, a lot of elderly people, they can't go outside anymore, so a hairdresser comes to them. And so these services exist, especially in Berlin. There seems quite a lot like that, or I guess more often, maybe, I don't know. And so they told me like it cost like my haircut would be 25 euros, and that person has to write half an hour to me, bring all the tools that they have, the taxes they need to pay, the time that it costs, and then again half an hour home. And then of course they don't have perfectly scheduled clients. They can't like do a lot of work, and I feel like 20 euros is so underpriced. So I gave them 40. I mean, you can pay easily 250 for a haircut if you use expensive colors, and if it takes longer, if you have to sit there and occupy that chair and the space in a place by a professional. Yeah, of course, easy 250. I feel like being a freelancer made me really appreciate the time that people like work for and put into. How much does €2 like kind of get you? Like is that is that, I mean, first of all, I think it's absolutely ridiculous that with globalization we have like cases where, you know, a smartphone still costs 200 or €500 for you, but it's normal that a person for a haircut only earns €2. Like, you know, crappy world. But disregarding that, does like €2 get you far with like normal life, with like paying for an apartment and that stuff? Your yearly rent is €510. Yeah. My yearly rent is, I mean, I don't know how you, if you calculate utilities in or not. It's like roughly like, I guess, €10,000. You can live on it, but barely. Yeah, that sucks. Anyone who cuts their own hair is crazy. Even if you are just like, make yourself a, what's it called? A clean shave. Is that even then crazy? Do you know this video here? What is this? Let's do a reaction stream.
Whoa, it's the Illusion reporting from somewhere on spaceship Earth. I got my little buddy here, right, Owl, and it's time to teach him how to keep your bowl cut tight because my hair is getting a little long. So you need a brush, scissors, a couple mirrors, trusty carburetor mirror, my old trusty Rusties, and we're gonna get into it here. First thing, super simple. You gotta brush it all out, man. You gotta get it all brushed. Now, see, I can't see anything, man. I'm like the Shaggy DA right now. So I gotta come across right now and just go straight across. Boom. It's a no hesitation move, the straight across. Just wham! That's it. Look at that, man. Look at that. Right across the deal. Rusty scissors kind of suck, but whatever. And then we just go right on down the deal, dude. Swing. Uh-oh. There are no mistakes in the world of bowl cuts. And you just...
I'll leave you with this amazing tutorial for a second because I gotta refill my drink.
Bring it right on back, man. You gotta go a little blind. It's okay. Just all you want to hear is that hacking sound. The hacking of the scissors. Now the upstroke, depending on whether you're right-handed or left-handed, is where it gets a little tricky. Now remember, you're trying not to poke your eye out. Oh, look at that. I got some hair back there, right? So I got this mirror in back so I can kind of see what's going on, but it gets a little tricky. And bam, downward angle because it's mirrors, so everything's backwards. Swing. Think I got that. Oh, yeah. What do you think, Al? How we doing? Whoops. Ow, ow. Uh-oh. Uh-oh, I'm lost in the mirror. I'm lost in the mirror. Uh-oh, I'm lost in the mirror. I can't figure out which way the scissors go! We're just going for it. Now it's straight across the back. Oh, I got it, that beaver tail out of there, that rat tail. All right, here, so let's see what's going on so you can see what's going on, right? Boom. All right, now I got to get back over here. That's where it gets tricky.
Asterix and Obelix tab. I think we all can learn something from him. Maybe not how we cut hair, but
you want to make some decisive cuts on the back. So
you can learn to have some confidence in yourself. Don't take yourself too seriously. You know, show that that you can, own it. That you don't need to let yourself be pressured from societal standards too much. I think there are a lot of things we can learn from him. It's not bowl cut maintenance, that's the title of the video. It's like self-esteem maintenance. Why are you frustrated? Yeah, but he is not in school anymore, and school is brutal. School is unfair. Okay, anyway. Let's continue. I guess blue wires now for up there. So I guess we just connect them also in order like that. So we start with the top. So B1 to B8, and they go to the data pins, all right. So from here to like here. Now that I get more and more, now that I'm more and more an established YouTuber, it's just a matter of time until I will color my hair. We have this cool YouTuber in Germany.
Moin, Servus, moin. Ich grüße euch recht herzlich zum neuen Video. Ich möchte euch heute meine neue Frisur vorstellen und wie das dazu gekommen ist, Erzähle ich euch gleich, aber guckt erstmal. So und so. Das hat auf jeden Fall was.
Again, another guy you can really learn something from. That kind of self-esteem. Like, huge respect. How did I just cut this so wrong? Wait, what? B1 from here. Wait, oh my god. How did that happen? Okay, now it fits. No. Now I made it like a millimeter too long. String email, those early memes. I'm not sure if I understand what you mean. We are still working, or yeah, we are working on the instruction register still, and we just talked a little bit about different hairstyles. Chill, dude, that depends entirely on what you want to do. Like where you what you kind of want to work at and what not. Oh my gosh, it's empty. Just a little bit left. Work in IT, the software dev or sysadmin. I mean, I personally always think academia really helps. I personally like university, but I mean, especially in our industry, a lot of people also make it work without any degree. I don't think that in an Ausbildung you particularly learn a lot about that stuff. You would only do it to have basically that degree. it would just be a way to like show somebody that you have some knowledge, I guess, with that degree. I don't know. I mean, I guess just based on statistics, it's always better to have the higher degree. The higher, the more likely it is to get like better paying jobs and all that stuff in terms of statistics. But that all breaks down when you go onto the individual level. You know, maybe for you individually it makes no sense. Maybe you just don't want to go to university. Maybe your job doesn't require university. Maybe, you know, there are many reasons why maybe you want to do an Ausbildung that makes sense for you personally. Yeah, and I agree what Cause Against Humanity is saying. At least if I would hire somebody, that's basically what, you know, what I would be looking out for. However, there's one thing about Germany, that Germany is pretty conservative when it comes to that stuff in the workplace. They love their papers. So I'm not sure, but and it definitely depends on the company, but generally I feel like that even in IT, Germany is probably a bit more looking out on the degrees. Like I know a lot of jobs where just based on the degree you have, you would just earn more. It doesn't matter what you, like if you do the same job, just because you come in with a higher degree, you are in a higher earning bracket. Just like that. Just company policy. You took a year off after school and I'm worried now that nobody will hire me. Play some CTF, write a few write-ups on a blog, fill up that blog like with a couple of write-ups, and then tell them you did a year off, you played CTF to kind of like study more, and here's the blog to show for. Solved. This doesn't have to be hard challenges, just something, you know. An employee will not look deeply into the challenges that you have solved. If they see, oh my gosh, this person has published stuff on a personal blog, that already looks so good, I think. Or your exam is on the 19th of July. You got enough time. You can start studying on like the 18th or so. Do you have the exam with like the always on camera? Are you in that kind of like thing now where you can't do it naked? You can do it naked, it's just weird. Yeah. It's a lessons of confidence, I tell you. You should just own it. You probably automatically pass if you do. I do have OSCP, but I only have that because my employee paid for a certification, and so I chose to do that one. Otherwise, I don't have any certifications. Also, have you heard about the recent drama with the Cyber Mentor on YouTube and OSCP, or the people behind OSCP? God damn it. Really sad. Really annoying. they rectified it together. Yeah, but it has been apparently a problem for like a long time or now that they go against criticism, and so I guess in this case, it was good that the Cyber Mentor has so good connections basically, and has such an influence. You know, this kind of issue is not the first time that it happened, and I'm not sure if the other cases were also rectified, because they generally, that's something that they do. They just feared now, I guess, more backlash than in other cases, I guess. So, you know, to me that still feels not rectified at all. I didn't think the stuff would pop out on my recommend since... You mean the Twitch channel? That's cool. Like, what are you up to usually? Do you... Like, what kind of streams are you watching? And do you have any kind of tech background, or are you, like... really just like completely like stumbled into something completely weird? Oh, you have a tech background, nice. Are you then also watching like science and technology, like other programmers on Twitch, or are you on Twitch just for general entertainment, like some gaming or just chatting or so? You want to watch Unreal Tournament streams? Over here. We want the blue one. You got a bunch of electronic stuff from last summer. I just do general entertainment, but I usually didn't come on Twitch much until recently. Nice. So what kind of streams are you generally following? Are you following particular people, or are you just always kind of like stumbling on the platform and clicking on something? Oh, Links, if you grew up on Counter-Strike, have you ever played the Counter-Strike surf maps? Was that a thing for you? Do you know that the guy who invented surf maps is also streaming a lot on Twitch nowadays? Yep. He is. He's incredibly nice. He's such a nice dude. He's pretty small also. He has always like just like, I don't know, a couple of dozen views. I wasn't really a Counter-Striker, but we did LAN parties when we were younger, and Counter-Strike 1.6 was obviously a huge thing, and what's his name again? Surf map Mario? Twitch.tv. It was like Mario owned or Mario
Qualifier.
owned or something. Sorry, sound. Oh no, I clicked on it. I have it in my followers, but I need to check on over here. 1 second. Mario owned. Okay. Here, this dude. I'm the guy who invented surf maps. I originally made them in CS 1.6. And so here, this video you need to watch. If you are into Counter-Strike, if Counter-Strike was kind of like a little bit of your childhood, then this is the video you need to watch. It's called The Story of Surf with Mario. Because of that video, he basically started streaming, and he got like for like 2 days he was incredibly popular, but now he's like a very small streamer. But he's so nice. He's so nice. I hosted him the other day. Yeah, I also played a lot of KZ maps. I will not be at DEF CON. Yeah, I should check him out. He's super nice. Like I said, I think he's probably the nicest person I've ever encountered on Twitch. When you see him streaming, you know why. He's like so kind. But yeah, that video is really cool. And he just like is streaming building surf maps and also sometimes playing them. Anyway, without Counter-Strike, your life would be very different. Yeah. Don't build with YouTube open. Yeah, ruined it, sorry. Okay, and now we are almost done. I need to add 8. Did I add the white wire? Definitely we got 8 wires for sure. Alright, we can actually count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. I miscount, what the fuck. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 20, 28. We should be at 28. Wow, I can add more. Okay, and now I think we just need to add the LEDs, and then it looks... Oh no, we need to pack this a bit tighter. We need the control wires up there as well. We need like 1 row at least up here free, and then even a bit more for, yeah, I guess 1 row should do. Where did you buy the components at? I bought them. Are you from Germany? That's why you're asking, because obviously depends from where you're from. I bought most of the stuff from mainly two different stores, from Reichelt and from Mauser. When I do long wires like that, I can usually get 2 on the same column. I actually have 2 on the same column, so these 2 are on the same row, these 2 are on the same row, these 2 are on the same, and these 2 are on the same. There are 1, 2, 3, 4. We have 4 rows here, And those are 8 wires. Those are 2 in a row, but we even need to pack them tighter. Are you planning to get hands on a Raspberry Pi 4? I don't really know what to do with it, so I have no plans currently. I mean, if I would have a plan with it, I would get one, but I don't know. I don't know what I would do with it. Don't know any local shops, thought you maybe order online. Yeah, I said I ordered on Reichelt and on Mauser, but it obviously depends where you're from. Are you from Germany is the question, because otherwise it doesn't make sense. Okay, bye, thanks for hanging out. Wait. Currently I have no plans to make a PCB for this. It's 2 individual desks just put as like this, you know. Just a basic desk. I think it's like each it's 170 long, 1 meter and 70 centimeters, I believe. It's like, yeah, it's like my arm length, like this. And they are in that configuration, but they are not like backed up fully against the wall like that, but that one is like shifted a bit forward, so there's a bit of space behind the other one. So this desk like stops here, but the wall goes further back, and there's a shelf where this camera is connected to, and things like that. It's not one desk. No, here's like a... I guess I have the camera just slightly moved higher, but it's like 2 individual desks. But it's like a movable desk. Oh, this is scary. Do you see that? It's too scary to do right now because I did so much on the setup on this desk that I don't know what I would break if I would now fully put it up. Yellow wires next. So what did we connect up there? This is the control wire, the second in the last pin. So the second is the clear. We connect the clear to and the G and G1. I don't know. I don't remember what that is. Okay, but we did that with the other registers too. Okay, so okay, now I see how it's connected. I just thought you meant computer science with CS. Do you think any like English speaking person in the US was able to trick their parents into thinking I become a CS pro, and the parents were thinking, oh my gosh, our kid is into computer science, but then he went off and played ESL? Thanks for the tier 1 sub, Taragon the Dragon. Oh no, my kid is into computer science. He's a nerd. Please play Counter-Strike like all the cool kids in school, please. How long will you stream? Not for too much longer, I presume. I want to finish this instruction register module, and that will probably be it. Maybe we angle them a bit more down here. I will have to set up notifications for this. I mean, yeah, you can just follow on Twitch, and then you should get notifications. By the way, there's also another guy who is streaming, like building kind of like a startup on Twitch as well, and it's called Notify.me. And so he's building that on stream as well. His name is Jamie, I think. Jamie Pine on Twitch. Oh, he's currently streaming. All right, yeah. And so that's basically a platform where you can like you basically subscribe on Notify Me, and you get all the notifications for all the different kind of platforms. So So here, see, I'm live right now. And you see the different like videos that I'm like releasing. Or when I've streamed and things like that. I have 8 subscribers on here. Yeah, I don't know. So he's building that on stream, so it's kind of cool. Might be a useful site if you kind of want to get notified. You ever thinking about leaving YouTube? No, YouTube is a great platform. I don't intend to leave. However, obviously, I want to diversify because it's not a safe platform. It, you know, like the content I'm creating has the potential of being seen too risky. Because, you know, it can easily be misinterpreted as like malicious hacking stuff. And so while so far my experience with Google and YouTube has been great. I have no reason to believe that like I would ever have issues. But I guess it's generally a good idea not to have all your stuff in one platform, because just like if something happens, then it would be good if you have multiple kind of different ways. So yeah, so that's also a reason, you know, it's one small reasons of many reasons why I also started on Twitch again. That's why I have liveoverflow.com again, and why theoretically, if I weren't so lazy, I would also post stuff on Facebook. And yeah. How can it be startup if he's coding it on stream? Isn't it open source then? Or at least public source? You know, just because you code it on stream doesn't mean that you publish your code publicly. I mean, it's like, you know, kind of recorded, but the license is not open source, so you don't have license to that code, and you cannot take it and use it yourself or whatever. It didn't sound so complicated. Have you ever written anything? Because once you build up something into a real product, there are so many small parts that you have to think about. Like not only front end, the back end, you know, getting all these notifications from those different platforms, manage, kind of distributing that for all the different creators on it. And yeah, I don't know. It feels like a lot of moving parts there. Just because it's open source doesn't mean it can. Yeah, and that's also true. There are a lot of open source startups. If you do NOP as exchange ARX exists, then the high bits of ARX are. Oh, really? Wow. Okay. If we would have made a bet, like what is the behavior of exchange ARX on 64-bit, I would have bet probably like $100 saying that it would leave the higher bits alone. And thanks for testing. That's really cool that you try to test that and report back. Okay, now only the LEDs, I believe. By the way, uh, how much do you got to you feel? Wait, what? What's the progress? Are you near the end? I'm not so sure. I mean, we are on video number. Do I have to play this? We are on video number 25 right now, and there are 44 videos in this series. But how much that results in actual like time and all those things considered, I don't know. I don't know the full series, right? Like, I'm working through this with you. I feel like we are pretty far. The modules that are only missing are basically just the program counter, the thing that increments and like handles maybe jumps or so, and then the output register and the instruction decoder. So it's still quite a few modules. Maybe half, I guess. Almost half, or a bit over half maybe. Does GitHub Enterprise give you the sources? Isn't GitHub Enterprise obfuscated? They could just give you a deployed like binary basically? So where do we connect that to? The worst thing about Reddit is their the worst thing about Reddit is kind of this culture around self-promotion, that they are heavily against self-promotion. I find that terrible. But I guess that's what the platform is built upon. Sharing stuff, not making your own stuff. It's encrypted Ruby. Yeah, of course. I mean, if they give you this thing on premise, basically, they have to give you their sources somehow, and it's, I guess, encrypted or obfuscated. As far as I know, it's not just a simple encryption key, right? Like that, I haven't heard about that, but I mean, it's still kind of like reversible or deep, like kind of understandable. Yeah. Have you heard about the Pi connected to a NASA server? I don't think so. Okay, so how can we place them here? Quick check. connect these differently. They stole some valuable data. I think I vaguely remember reading that. I wonder if it was just a kiddie who just thought it was like, who like watched some shitty YouTube tutorials and then got a tour through NASA and just plugged it in somewhere, or if it was really malicious. I mean, how the heck would it get in there? Does the article say anything about that? Yeah, there are always buses driving on that street, and that's also my problem when I record audio for videos. They drive every few minutes, so I constantly have to pause and redo again parts because they're just even with closed window, you hear it. In some videos, you see some comments where people are writing that, oh, what is that deep kind of like humming noise or so? Those are the buses outside. This is when I forgot or didn't pay attention or so. Or didn't care. Sometimes I'm also just lazy and I'm so mad at it and so angry that I just, fuck it. Sometimes I'm thinking, maybe I should move in a different place where there's like less noise like this, or where here the problem is I have a huge window front, so I can't really soundproof it. I mean, I have already the curtain in front of it, but that doesn't really help. So sometimes I'm thinking, maybe I should move in a different place. However, so far the neighbors have not even once complained, and that is good because I often up until late into the night, and I might be streaming late at night. I might be recording videos late in the night, and never have they said anything. And that is incredibly valuable because we hear their baby crying all the time from downstairs, which means they must hear. Oh, it must hear me. What's your problem, buddy? Go check it out. Brr, 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 brr. Okay. Looks pretty good. Looks pretty good. Oh, I had the wrong screen on all the time. I'm sorry. I don't need headphones for noise cancellation. It's not that noisy. I don't really care. It's the problem for recording. The problem is the microphone. So. The core functionality is crawling a bunch of APIs, saying that data push API I can cobble together a similar Python script in a day. Yes, but it is very different from then having to scale that up to dozens, hundreds, maybe thousands of creators you need to constantly do. And it will not be a simple crawler because you don't want to constantly ask if there's new stuff. You want to use a different protocol. Basically, you want to be notified by Apple and Android, Apple and Google if new uploads and so forth have come in. So you need to have a completely different model. You need to keep all these connections open to listen to incoming stuff. You need to, because like a pub subscribe thing, you need to have sensible recovery. What if your connection breaks? What if like the service has an outage? Faulty data coming back? You need to handle all of that. Your simple script, you don't care about it. If that breaks, you just restart it or so. But for proper setup, you need to think of all the different cases that could go wrong. Yeah, I don't know. I'm saying why streaming isn't a big deal. What do you mean? I mean, I don't know the API that they are using. Might be WebSockets what they are using. You can also have like long living HTTP. So the idea is that you initiate the HTTP request, but the server never responds yet with a response. It just keeps that connection open. And so you initiate that connection once, you keep the socket open, the other side keeps the socket open, and as soon as there's data, they return it. And you don't need to immediately return. You can also, keep streaming data. How in the same way how you like download a large file over HTTP. It's not a single response. It's like multiple responses streaming it slowly down. That's a lot of sockets. Yeah, and then there's the other thing. Maybe you can subscribe to this for multiple. So you can like keep one socket open for a number of creators. I don't know, but that's the thing. That is what goes into the engineering and why the code might be pretty complex to have all these, all these different considerations you have to keep that working with a lot of things. I'm not so sure if YouTube does the YouTube API even have like a webhook API? YouTube webhook. I'm not so sure if they have webhooks. I don't think so actually. Subscribe to push notifications. Okay, maybe they do have. Let's see how this works. Callback URL. Okay, yes. Okay, so. Okay, I guess you can receive push notifications. Okay, that seems then. Oh, I know for a fact that Jamie is using that. He mentioned that to me. Via PubSub HubBub. It's such a funny name. So this is what he's using. Oh, yeah. Yeah. But the difference between a simple hacky script and a full product platform is miles of difference. And look at that design. It looks like professional. Like, this looks like a stereotypical website. It looks amazing. Oh, more result. Yeah, for sure. Yeah. I mean, there's also, there are a lot of developers that stream their non-public work. Adam 1355351. 13531. There we go. Adam is streaming Botland, developing Botland for like 2 years or so now. It's also not open source. Making a chat similar to Discord. Yeah, stuff like that quickly explodes. But you learned a lot. Yeah, of course. That's always like what you get out of it. Okay, wait, I wanted to watch this video and see now how. Here. I added all these LEDs now. That's a Turvis mug. It's like Turvis. I believe it's the 24. Yeah, here it's these kinds. In the US you can get them with basically any design. They exist a lot also as like merchandise articles everywhere.
And there we are. So our bus is hooked up, power's hooked up. Oh, we do need clock. Make sure that's hooked up. So our clock is here, and that should hook up to our. No, it doesn't quite reach, but we can. That's okay. We can just connect it over here, as long as all of our clocks are connected. There's these white wires. So our clock's connected. Everything's connected. So what we could do is we could go ahead and output one of these registers. Let's take the B register, and we can output that, and then we want to input that over here on our instruction register, let's say. So let's see which one of these. This would be the load. So if we take that low on the next clock cycle, yep, we've now inputted that value, and so now we can stop outputting that. Oh, right. Got to make sure once we read it in that we are no longer loading, and now it's safe to take that off the bus. and it'll stay there. And so now we have that in there. Now, remember the one difference here is we don't have these top 4 bits hooked up, the blue LEDs. That's why I did them different colors, is they're a little bit different. The blue LEDs aren't hooked up to the output. So if we enable like this, we see only the lowest 4 LEDs come on because the blue ones aren't hooked up. These blue LEDs are going to be hooked to another part of the computer for the instruction decoder, because this is the instruction register, and these four bits are going to have the instruction. They're going to go to the instruction encoder. These 4 bits are typically used for an address or something, and they could go back out on the bus. Don't worry if none of that makes sense. The point is we just don't want to connect these top 4 bits for one of our registers here. And so if we want, we could, if we read this back in to somewhere else, let's say we load this into the A register now, we end up with that same value there. And then we can stop loading that in the A register, and then we can stop outputting that on the bus. And so now there's nothing on the bus. And so now, we could load this from the A register to the B register. We output it on the A register, it goes out to the bus. And on the B register, we change our load pin here, and it loads it in there. And so you can see we're getting these bus transfers. Each of our registers, it appears, is able to output to the bus, and each of the registers is able to input something from the bus. So it looks like we've got our 3 registers built: the A register, the B register, and the instruction register.
Okay, I guess let's quickly also verify that this works. It's a bit tedious with all the wires. I'm getting so tired. I almost fell asleep there. You can connect over here. We can we need to connect the clock. Like that, and then we smoke test, yeah, burn and test. And then we also need like the this enable. So this should be the input enable. And then in the front there, for the bus transceiver, we want like an output, if it's outputting or not, which should be this pin here, which we put to disabled. Is that all? We have clock. Oh, the clear. The clear has to be connected to 0. So clear. Wait. This is clear. Disabled, and this goes to, I guess, here. Okay. Oh, we need the power rails here as well. I'm kind of sad that liveoverflow kept the magic smoke from escaping so far. I agree. I feel like some smoke would have made this a lot more exciting. Not even an exploding capacitor so far. Okay. Oh, this is short circuit potential over there. Okay, so now everything should be connected except, wait, we need to put this the other way around. We should take this over here. The clock was also missing here because we need to connect to the bus. Okay, so now we only need cables here to the bus. I guess we can disconnect these up here, I guess. Oh no. Okay, now I ripped out an LED. Where does the LED belong? Here. Let's move this all closer to make space. How you keep balance with dev, hack, sport, relaxing? No relaxing, no sport. This here is kind of relaxing, to be honest. So let's see, we connected just to get like the bit order. So this goes to the first one, so this goes to the first one here. Okay, so that is connected. YOLO Jens a couple of years ago, and through connections somebody knew somebody and recommended me. Yeah, we could have also like hooked up, prepared the real bus. It's also something we still have to do. Okay, I believe now it's kind of all okay. Now let's quickly think. So this circuit over here, this one here has, oh wait, what's this red wire? Okay, whatever. So this here is input disabled, clear disabled. and this here has output disabled, but is connected to the ALU. This here has clear also disabled, but has reading enabled, so it's reading from the bus, and itself has output disabled, and this here has the output enabled. So this is this decrementing loop. Now this over here, we will have the clear disabled, we will have the input reading, let's enable that, I guess, but we just need to make sure that the output here is disabled. Okay, let's turn it on. Oh. Okay. Okay, yeah, that seems to work. So this circuit here is constantly doing that, you know, that subtraction and so forth. And you can see that here nicely. And this is configured to read from the bus, so it keeps reading with each clock cycle that value in. And so these two registers should basically always be the same. So I'm just observing this now, if this is counting correctly. There's something glitchy about it, no? Was it always delayed by one? No, okay, so now it's, there was something very glitchy about it. It didn't always work. So, see? Oh, no, wait, no, wait. Well, okay, slow the clock speed down. Yeah, I mean, first of all, it should still work at that clock speed. I mean, that was like super slow for what this should be able to do. But even now by hand, see, it's kind of glitching. Both these registers are configured to read from the bus. So it's kind of interesting that this bus gets out of sync so much. Did this just glitch? Is this what glitches? I feel like this is glitching sometime. Okay, to be fair, maybe that has always been glitchy. I've never looked at it so hard, because the thing is, yeah, it might, wait. Yeah, the thing is, I'm thinking is because this is kind of like a circle, right? Like this register is always like influencing the adder here, the ALU. So the ALU creates a new value, immediately puts it out, and this immediately reads from it. So could that mean that, you know, it always reads that new changed value? Could that mean that sometimes you glitch it so that kind of it reads its own result again and does it again or something like that, and does clips measure clock voltage? Yeah, that could also be a thing, that there's just the voltage levels are kind of getting to weird levels where it's just kind of glitchy. That could also be. Null comma 4 volt, something is wrong. So if I measure up here and ground, and I have the clock, I measure 2.8 volt. That's low. It's not current limiting. The voltage level over here is 3. Wait, sorry. Like over here it's 3.8. Okay, I think it's just voltage glitchy. It's kind of far away, that connection. Let's see if we plug that. Oops. Short circuit. If we plug it in here. Now we have a higher voltage level here. Now it also draws more current than just before. I guess some stuff hasn't working and properly. Like some gates might not have kind of like worked, because it draws now 0.2 amperes more than it was when I had it power plugged in somewhere else. So I guess like some stuff was just not really working. But it seems to have to solve it, right? It looks now pretty good. Yeah, I think that's okay. Measuring clock with DMM might not be the best. You will get the MS value, not the peak. Yeah, but what if I just keep the clock high like this? You know, it's just like I'm measuring now the voltage that this thing is outputting. It's like basically the LED is on like constantly up there, the blue LED. So if I measure, yeah. It also has a peak button, but the question would be how short kind of it is. I don't know. But yeah, I mean, if I keep that pressed, that's basically what I've been doing. I pressed that consistently and measured basically what the output of that is. But yeah, it looks fine now, I guess. Like, I think it was really just like the voltage levels getting kind of low. The clock was probably not also had weird voltage level. Yeah, I think that's why it got glitchy. We really soon have to properly connect here power rails. Like, these are not good enough. Okay, but yeah, looks good. We finished the instruction register. I'm satisfied with that. By the way, do you also think that my wiring has gone better over here? This looks, I feel like, way cleaner than this build, the original build here. Jumper wires are bad for power. Yeah, I know. By the way, people who haven't been here, did you see our new clock speed selector up here in the corner? The potentiometer that we are using now? It's a wheel. Do you have capacitors on the board on the right? No, I don't think so. Should I put one there? Are you getting voltage drops along the power distribution? Yeah, that's what I believe what happened. Now it's fine. We moved it further into the middle between both modules and now it seems okay for now. But yeah, it's generally a problem that we need to improve. I saw on another build, basically somebody used like a bit thicker wire than what we have here. Thicker wire than this. And then he just made a long line around and soldered connectors to that wires because solder connections are like perfect. So that power distribution was perfect, and then only was going into the single rails of the breadboards, and so that should be it's kind of the best way how to do it. And so I wanna do that also soon. TM. I don't know. I guess I might do this as soon as we kind of like have everything further in place. Like proper like the bus setup and we know where this goes and then we can measure this properly. Sprinkle, yeah. Anyway, okay, I'm getting super tired. We did make some good progress. I definitely need to go now. Yeah, thanks so much for hanging out with me again. Today was a bit slower and more tired, but I guess tomorrow I should be back on speed now that I have basically adjusted again to my sleep schedule now. Yeah. Let me see, who could we raid today? I guess we could raid Jamie. Otherwise, nobody of my followed channels is streaming right now. Lana looks is again streaming, but she has 100 viewers. Jamie has only 50. Like a professional electrician, need to move to another category. Yeah, let's better quickly end the stream and host somebody before the police catches us. I guess guess let's host Jamie, and then we see each other. We see each other like tomorrow. Okay. Nice to see you on Twitch. Well, was a short meeting. See you hopefully soon another time. Bye bye, and say greetings to Jamie.